Gwen Shapira here. Thanks for being at my talk. I wanted to talk about how you think about performance improvements as a small startup in the very early stages before you really find your product market fit. So, just a bit about me and how I got here. I used to lead the cloud native Kafka org at Confluent. In general, I spent a lot of years of my career doing Kafka things. And before that, I did all kinds of databases, starting very early in my career, Oracle, and then MySQL, and then a bunch of Hadoop things, Spark, Impala, which led me to Kafka. I did a lot of performance work at every one of them, all with data systems. So all my experience is basically database down, things like memory and CPU, network storage, etc., etc. But 2 years ago, when I left Confluent, I started a company and I found myself responsible for the performance of an entire stack. And this was very different, doing performance of different things with a small team, not a lot of budget, a lot of questions. Nobody ever told me what's the right way to do it. So I thought I'll share my experience. And this talk is very much the type of talk that is basically kind of sample size one. So I'm sharing my stories, I'm sharing the trade-offs I made, the decision I made, how they all turned out, and it's all my experience. So your mileage may vary, but hopefully it will still be interesting stories. Now, the biggest thing that everyone tells founders about performance is don't worry about performance. In general, founders get a lot of advice on how to run their company. Don't worry about performance has been a repeated theme in my life. Don't worry about performance until you have users, until they complain, until you have product market fit, until you have scale. It's a good problem to have. People always complain about performance. If people don't complain about performance, it's not a big deal. But if they do complain, that's really good. Like all those kind of things. I disagree with all of it. For me, performance is part of the product. And when we started the company, we did, and we're still doing, a lot of product research. We talked to potential users, potential customers, ask them about what products they currently use, how they think about it, the problems they have, their pain points, how we can help. You always try to figure out the minimal feature set that you can go to market with and make an impact. And performance is part of this package. And you should discover performance expectations of your target market at the same time that you discover any other expectations. This is part of the product. I don't see any reason to leave this out, essentially, from the discovery phase. What you do with what you discover is a different story. And I think there is two very different types of companies that you discover who you are and ask questions accordingly. So some companies, maybe like SailorDB, their performance is a core value of the product. If SailorDB is not high performance, what is it really? Like for many years, the majority of the pitch was like Cassandra, but faster. So the kind of discovery is, okay, we want to win in the marketplace because we're faster. How much faster do we have to be? Faster at which operations, in which circumstances, what kind of deployments? There is a lot to discover about how do we beat competition on performance. But then there is the rest of us. We are trying to beat competition on some subset of features and or wedge or some combination of a pain point that we're solving that nobody else really addresses. In those cases, we still need to talk to our customers about performance because our customers have implicit performance expectations about a product, and we need to discover what they are. So let's say you are doing, security or network monitoring. If you talk to your customers, I'm 100% sure that you will hear things like, this is too much overhead. We would love your product, but if it makes our own product 5% slower or less throughput or more expensive, we are no longer interested. Or for web applications, as you know, if your web app is too slow, people will just wander away from the page. Nobody really likes slow internet. So you need to make sure that in your conversation, kind of discover if they have some performance expectations that are specific to the industry, the type of performance you have, what they're actually used to in terms of performance. Ask them to click around to show you what they're currently using and what it looks like. So one of the things that everyone tells founders all the time, oh, just ship something that you don't feel good about and see how people react. So first of all, I agree, and we're going to do it anyway. There is 100% chance that if you do a startup, you will ship something that you're not 100% happy with, and you'll see how people go. But the reason you ship early and iterate is because you really want to learn fast. And if you have already learned performance expectations at the discovery phase, try to ship something in that ballpark. Otherwise, I'm not 100% sure you're actually learning all that much. You knew it's going to be slow. They told you that before. And then when you ship, guess what? It's actually slow. It's not that good of a learning. At least clean out the low-hanging fruit to make sure it's not... You already applied the learnings that you kind of know you're going to get, kind of thing. The other reason that I believe shipping broken stuff and learning doesn't always work is that you only get feedback from the users who actually care enough about your product to give you feedback. This can be good, but also it means that if your product is so dog slow at some part of the world, you may never hear that it's completely unusable by some subset of your customers, because guess what? If they completely couldn't use it, they may never come back and tell you your product is unusable. It's like the planes that come back and you can see where they have bullet holes versus the ones that didn't come back. And the ones that didn't come back are actually way more important to fix than the one who did come back with some user bullet holes. So this is another thing to keep in mind. So I'm going to talk about two aspects that I found really important starting up, like the things I wish someone told me about. And the first is that as a small startup, you want to get to the market fast with reasonable performance, and you don't have that many resources. You don't have a lot of people, and you don't have a lot of time. You don't have a lot of money. You need to focus, and the right place to focus on the user experience, because this is the reason we want to have performance in the first place, right? To land those customers. So I'm going to talk a bit about how we hyper focus on user experience, and then I'll switch to benchmarking because everyone loves benchmarking. So there are obviously a lot of types of product. I'm going to spend the next bit of time talking more specifically about web apps, and for two reasons. First, they're pretty darn common. And second, even if your core product is, like this network monitoring ePPF, you're still probably going to have a website, and it may still be very early in your customer experience. You will have first impressions based on that, so it behooves you to make it good. But the lessons I share are generally applicable in case you're not into web apps. So what you're seeing in this picture is what is called Web Vital metrics. Those were decided by the Web Performance Group. And the particular product that generated those is the Google Lighthouse. And when I first encountered them, which, remember, I only did databases until fairly recently, so this was a new learning for me, my first impression was, oh my God, web developers care about performance. I was under the impression that if you spend your life writing in JavaScript, you probably don't care about performance. It turned out that even though JavaScript is still a popular front-end language, web developers actually care a lot about performance, to the extent that they have good tools, the vendors that sell to them, the frameworks that they're using, they all, to an extent, compete on having great performance. So this was good news. The other thing I discovered is that their idea of performance is extremely user-centric, far more than I ever encountered before. Very tailored to a user is sitting in front of the screen, looking at trying to do something. What is their experience? So they're talking about how long did it take to load the first part of the page, or the biggest part of the page that everyone cares about, or did any part of the page move while it was loading? Because you know how annoying it is when you try to click and it moves by 2 millimeters because the page just finished loading. They look at all this kind of stuff. So this is pretty cool. If you looked carefully, you will notice that all those metrics are really about the perceived latency from the user point of view. This is good because startups very rarely have a scale problem. If you do have a scale problem, you can do things like put everyone in a wait list for a bit while you're figuring out how to scale out and add machines. It is pretty rare. Latency, on the other hand, even if you have small number of users, you definitely care about them having great experience with low latency. You still care about scale in the sense that please don't hurt your own scale, but we'll talk about it later. The other part is that it's not just latency, it's perceived latency, which is different. And you probably know the thing when an elevator goes up and down, and when you're in the elevators, they have mirrors. And the idea of the mirror is that if the elevator is slow, you can kind of entertain yourself by checking how you look and don't notice how slow the elevator is, essentially. So we are trying to create a bit of latency hiding by user experiencing in the web as well. And this is very much the thing that I also think is a good idea to optimize for. The perceived latency by the user. This is what matters. So one case where we had to solve for that was that our login page, of all things, were taking too long to load. And this was important for us to solve. Like, you always prioritize. Why did we prioritize this? Well, first of all, login page shows up very early in the experience. If people cannot go past that, you don't have users. And also, there is absolutely no reason in the world for a page that's simple to be slow. What turned out was that we ran the web app on what is basically serverless compute. We chose our particular web compute provider because they had amazing developer experience. There are several providers who are more modern. They provide deploying web apps with amazing developer experience. A lot of them, if not all of them, are serverless compute, which is a serious problem for startups, as we discovered, because remember when I said startups don't have a scale problem because they don't have that many users? Well, guess what? It means that those instances spend a lot of time being idle. And a property of serverless compute, if something is idle for more than, 15 minutes or something, they basically shut down the machine. They'll start it when the next person makes an HTTP call. This means that for a lot of your HTTP call, the spin up time of the machine actually counts toward your latency of the first page. And you also, like, all the startup costs basically count into that. So this was something that we didn't realize we will have to optimize. We end up having to look at. Obviously, if you have a static page to serve, CDNs are pretty awesome at that. We also learned that when it comes to optimizing web application start time, there is a lot of advancement in the last 2 years in that space because serverless has been such a big deal. So if you're using Java, there is a ahead of time compiler. In the JavaScript world, as JavaScript usually does, there's like 4 different faster Java runtimes who are trying to solve this problem. Doing more optimized builds has become another area of active improvement and research. So definitely this is where we spend a lot of time looking. We got major improvements, worth spending time on that. And obviously, if none of this helps, you can always go back to provisioned compute and the more kind of harder to write, but more usual deployment pipelines. So let's say you logged in. The next thing we wanted to show you was a really impressive dashboard. We worked hard on it, and it was important for us because we really, really wanted to impress our customers. And we wanted this page to load, in a second or two, so it will feel good and be impressive to our customers. We discovered that the range of response time on this page was anything from 200 milliseconds, which is great, to about over 10 seconds, which is terrible. And the long tail was pretty darn long. So we started looking at this page. First thing we did was start drawing the boxes and filling in the numbers as they show up. So we parallelized the requests, and if any of the results showed up first, we could fill in basically the right box and have a nice interesting user experience. You progressively get more data to look at. The second thing we noticed is that if you parallelize the requests enough, you learn that you're maybe doing something very inefficient. And in this case, you see the box that says that there is 2,000 accounts, and then there is the box that says 62 open tickets. Well, we didn't have an API for how many tickets, or even how many open tickets, or give me all the open tickets, nothing like that. What we did have is, given an account, give me the list of the open tickets. So this poor page had to run this, basically make 2,000 fetch requests. Not great. This is like, it sounds horrible when I say it that way, but it's actually very common, very well known. It's called the N+1 problem, where you don't have an efficient API, or you're using an ORM. The API is efficient, but behind the scenes, what is driving the queries becomes inefficient. So you end up just doing query for each, where you could have run something bigger and get more results at the same time. Obviously, queue a round of API improvements, a lot of tuning, just to make everything exactly the right fetch size, not too large, not too small. And then our front-end guy discovered that since we are getting usually even more information than we wanted to display on the page, he can actually cache a lot of it on the browser and make a lot of the subsequent clicks around that always come when you have a nice dashboard, make those a lot faster, because they already serve data that was pre-cached in the local storage of the browser. So more improvements came from that. Caching is amazing, as we all know. And the last thing we did, this is still, with everything we did, it's still a pretty data-heavy page. There is no reason, our customers loved it, but there was no reason it had to be the first thing that everyone sees after logging in. You can move it aside. Not everyone needs to see those reporting all the time. So you can put it in a second page, put a much simpler landing page that is more focused on navigating around the website or getting tasks done, not so much on reporting. We don't know if we'll stay this way. We're still experimenting with a lot of things, but this was definitely kind of learning opportunity around where to optimize and how much to optimize. And then the next thing I want to talk about is benchmarks. Now that we kind of optimized all the front end low-hanging fruits, I want to talk about benchmarks because as performance people, we love benchmarking. I'm guilty of that as well. And you can essentially spend infinite time benchmarking with very little to show for it. So I want to give some tips on how to spend less time and have more to show for it, and share what didn't work for us. So first of all, really important, benchmarks should kind of pay rent by answering some important questions that you have. They are time consuming. If you don't have an important question that a benchmark answers, don't run a benchmark. Here, I just saved you weeks of your life. Those are important for startups. You can thank me later. There is an exception, which is if you belong to the my product has to win on performance, the SiloDB kind of company, you have to run what we lovingly call benchmarking. Basically, benchmarks that the goal is not to answer a question, but show off how much you perform and how cool you are, because this is how you're going to win in the market. If this is what you are, you know what to do. I'm going to talk about the rest of us who are just trying to have a really nice to use product for our customers, and performance is part of the equation. So you need to have questions. So we'll go after one or two good questions that people normally ask of benchmarks and share how that went. And the first question that always comes up is our DB setup good? People are very paranoid about it, because once you're in production, making a lot of DB maintenance can get a bit tricky. So people usually want to test it before going production. And that was my life for a very long time. Just go to customers, test their performance, and give advice. Usually you use a standard benchmark like TPCC, Swing Bench, one of those things. You increase the load over time, you look for bottlenecks, and you fix what you can. That's the drill. And being me, I actually did it at our startup with one of our top engineers. And well, let's say that it's an exercise that I would not recommend for a startup, maybe for bigger companies. What happened was that, first of all, running the standard benchmarks, when you're not used to doing it week in, week out, it takes time and effort. It takes time and effort to change all the knobs and parameters. It takes time and effort to analyze the results, rinse, repeat, even find the good tools these days was not easy. After we went through all that, we did find some configuration issues. We fixed them. Like those were the low-hanging fruits. It was fantastic to find and fix them early. And we had some idea of the performance we can expect, but because it's standard benchmark, I don't know how well it really maps to what users actually do. It's okay-ish. Overall, I thought that, you put in a week or two of effort and you get some parameters to tune and some idea. I didn't feel the ROI was exactly compelling. Obviously, if you're a performance expert in a startup and you already have everything available and you find it super easy, if it takes you like a day, it's probably worth it. But if you have to get up to speed, you haven't done it in a while, you have to figure out how to do the setup, meh. A better question is, do we deliver good experience? Will we deliver good experience for something we haven't launched yet? And which leads to the question, what is a good user experience for you? And we talked a lot. Everything on the user onboarding path being fast is important to the user experience. I highly recommend focusing on that. We also discovered that anything your developers think are annoyingly slow, also worth fixing. If it annoys yourself, it is incredibly likely it will annoy other people as well. We discovered it time and again. And then there is a case of things your customer obsess over, which you discover while doing the customer discovery and talking to a lot of them. You discover they can obsess over the weirdest stuff. So this is an example from back in my Kafka day, and it's out of a paper that my team published on Confluent website. You'll have a link in the notes. And basically the idea is that inside Confluent, at least in my team, we cared about end-to-end latency. You produce something until when can someone consume it? That was always the number we tested and optimized for. We discovered our customers cared about a very different number. They only cared about produced latency. To this day, I'm not 100% sure why they cared about it. Sends are async. Nobody can use the data until they can consume it anyway. What do you care? More important, produced latency was a metric in the product. It was not well defined. Depending on configuration related to availability, it could be one of any three things, causing endless confusion as we try to talk about why is the producer slow, especially when the producer is async, and why do you even care that it's slow? So tips, don't have metrics that means three different things. It's extremely confusing. It covers everything from client internals, network time in the broker, replicating stuff around, depending on how you set stuff up. You cannot really argue with customers, essentially. We spent a lot of time trying to educate them. All they wanted to know is about produced latency. In retrospect, I should have redefined the metric probably 7 years ago, and everyone would have been a lot clearer talking about performance. But the thing is that you cannot tell customers to stop obsessing over the things they obsess about, even if you don't get it. So you need to figure out ways to make them happy, ideally without helping them shoot themselves in the foot by setting low availability configuration in an attempt to get performance that they effectively don't even get the benefits of, just a lower number in some screen. The other important thing is to have those tests be stupid simple. I'm talking about time to load a single page, time to run a single query, not in parallel, just the time to run this single thing, maybe 5 users in parallel. Like, definitely don't try to mix a lot of smart workloads. This is just for your own sanity, to be able to do it fast, iterate fast, and analyze the results, and not get overwhelmed by data that you don't know what to do. That's a huge waste of time. So a few things that helped us with those simple tests. First of all, because of those simple tests, we didn't need any fancy tools. And we included extremely simple tests, like loading an empty page or querying an empty table. Why? Because if those are slow, you probably want to fix it before you run anything more interesting than that. You will not get any better results. Very important to check return value. Very common, not just with me, that you think you have performance numbers, but you have performance number of the load balancer telling you that the application is not even reachable, the famous 502s. You may get back empty results when you expect the data because you had problem with the setup, not what you wanted to test. You may think you're testing a write pass, but due to DNS routing issue, you're actually testing a read pass. We've seen someone do that by mistake. It's important to know that what the numbers you're testing actually relate to. And the last, actually analyze the results. And if you cannot analyze the results, you need to think about how to get results that you can analyze. Overall, if you can do all this, the return on investment is amazing. You run something very simple for 5 minutes, you figure out what it was, that takes a bit longer, and after you fix it, it's 5 minutes to run the thing again. There is not a lot of overhead. So we really liked the return on investment here. Of course, very important for the return on investment that when something shows that something takes too much time, you will be able to answer why. Now, at first, almost nobody can answer why. The trick is that the instrumentation you're doing while you are going through the tests, while trying to answer why, adding the tools, adding the numbers, this is the real benefit of the test. Because you will not have time to fix everything. You'll fix some stuff. You'll ship it. Customers will complain about performance, hopefully, somewhere else. And those numbers, those instrumentation, all the observabilities that you put in now, this is going to be the gift that keeps over giving for the lifetime of your product as you continue to build into it. Being able to answer the ubiquitous, why is it slow question. This is like 80% of the benefit of the early startup benchmarking is actually getting the numbers that you can use later when more questions will come up. And this is very much a gift that keeps on giving. Then when you get results, we prioritize them basically normally based on ROI. We had a scenario where we discovered that out of a slow request, it was like 40% parse time, 40% doing some lookups, and then like 20% real work. The developer who looked at it said, oh, I think I can reuse an existing library to make the lookups significantly faster. And it's not going to take very long because all the setup is actually there. I already have the cache, I just need to properly use it. This is great. That's a quick win. We got 40% of the time back and with not a lot of effort. If he would have told me, hey, I'm not 100% sure about the caching, but I have this really fast JSON parsing library, fantastic. We have another quick performance win. So you're kind of looking for the stuff that your team is very confident that, hey, I know what to do here, kind of stuff. That's the return ROI you're looking for. Low investment, fixing the biggest thing. And last but not least, sometimes we really don't have any time to optimize. But if you have a team of experienced engineers, they know not to pessimize. They are familiar with those, faster JSON libraries, async libraries that do stuff behind the scenes. They know not to put slow stuff on the critical path. There's a lot of things that are kind of like not even worth the debate, not even worth the testing. If you know a way that's generally faster to do things, even though you don't have time to prove that it's actually faster than any other way, just put it in. It's not premature optimization. It's just avoiding premature pessimization. You may be wrong, but it costs you nothing to do what you believe will be higher performing than other alternative, even without proof. I notice that for senior engineers, most of the time, it's common sense stuff and it just works. And that's it. Thank you very much for being here and listening to me. I hope you learned something, and I'm wishing you high performance applications and successful startup. I put here my contact details if you want to contact me and tell me I'm wrong on the internet.